Oh, hi everybody. I'd love to introduce Martin Wikelski, who has been, analyzing the flow of animals to understand kind of the health of their ecosystems. Welcome, Martin.
Thanks a lot. Yeah, it's great to be able to talk to you. We think we are at actually a revolution of understanding the globe, understanding life on the planet, and that is through the Internet of Animals. And that's how we can also do a behavioral mimicry, a biomimicry to really benefit from the collective wisdom of life. So what we have already are, at least on the terrestrial side, real-time data on how animals move around the planet. And that is pretty amazing because there are billions of data points that we have now really all around the globe. It's very simple to understand the principle. There are intelligent sensors. It's a sensor swarm. You all know this best from Google traffic. It's a perfect system that nobody expected even 15 or 20 years ago. Now everybody uses it. It's totally amazing. And you can do exactly the same with animals because they are better sensor swarms than any cell phone that is in a car. They can measure their environment and their surrounding a lot better. But what do we need? We need animals who can communicate with us globally by wearable computers. And then we can observe and predict all kinds of systems, and I'll go through those. Now, what we can do, obviously, since the area of Sputnik, more or less, is to put tags on animals. It has been started in Illinois by a friend of mine, Bill Cochran, in the 60s. We can do this on small animals, on the very small animals. We can do this also on the large animals, also with small tags. This is a newly developed ear tag on a rhino. Rhinos can only have below 20-gram ear tags, otherwise they drop out. This works beautifully now. We have hundreds of those around in South Africa, and they communicate all the time. But they do this all around the world. Here a picture of the Alps, but this could be the Sierras. It doesn't really matter. We have now more than 100 GPS points per solid square kilometer of Earth if you calculate it on the whole Earth. We have more than 15,000 animals feeding live data into MoveBank, often very many data. The database is growing by 6 million GPS points a day. That doesn't sound much, but for animals to produce them anywhere in the world, that's actually quite a challenge. You can look at those animals if you use the Animal Tracker app. Not all of them, only those that people share. But there are hundreds of species already in there. And more or less all around the world, there are white spots on the globe, and a lot in the ocean is still done by different systems because they do different communication styles. So the Internet of Animals exists, it's growing, and what can we do with it? Well, first of all, there's still one thing that we don't yet have, and that's an Internet of Things satellite connection. We have actually established that through the Icarus system. We wanted to have extremely low tag mass and size, simultaneous communication, and all around the globe. And that is a dedicated channel that we had initially with a huge antenna because people predicted we couldn't do that. Put it on the ISS as a rapid prototyping, which in the end it wasn't, and we had it on the Russian sector. So that stopped a year and a half ago when the war started. But it's still up there. It's still sending data down, a downlink to talk to our tags. But overall, the system is nicely tested, but for us it's dead. It's not working anymore. But we are currently producing CubeSats, microsats that do the trick. They are much better. They're much more versatile, and the first one is being assembled now. It will go up in about a year, less than a year from now, with SpaceX. The tags are, even those ones that we have here, they look small. They are still way too big, about half too big for what we want to do, but they are shrinking starting from January. We are re-engineering all of that to have them on small birds, on any kind of small animal that roams the planet, and link that back to people. These are, for example, common blackbirds in Europe, and this was before the war in Russia. But now we have them talking to us in real time across the globe. We also have data that are beautiful long-distance migrations, for example, from common cuckoos, just one of the many species we studied. We have the short-distance migrants that go from Norway to Angola, the mid-distance migration from Mongolia through India to Angola, and the long-distance one, the longest distance you can have on the planet over land, Kamchatka to China to India to Eastern Africa and to Angola. So very exciting that they all meet in some areas. And we have that developing on a global scale from the Icarus project that we will soon have back again. And there's a whole community of people, the biologging community, who is working on that. Now, what can we do? One of the first things that's exciting is that we can change weather and climate predictions, make them better. For example, we have griffins in Bhutan. We thought they're just roaming around in the little country of Bhutan, sort of the Switzerland of the Himalayas. But in fact, they go through China, they go into Mongolia, they go into India from 70 meters to 7,000 meters. They tell you how the wind is blowing, what the thermals are doing, how the turbulence of the air is, and that can be used obviously to predict climate and weather first and then climate.
So let me actually drill down on this one, because this is a novel sensor I was not aware of until now. If I put up a balloon, I can pretty easily track its the wind gradient.
Yes.
These guys don't just flow with the wind, I'm assuming. I mean, to what extent are they different from a generic balloon?
Well, they can go anywhere. They do it on their own. They're autonomous units, obviously. You have to interpret the behavior because they choose their environments. You have to know what they choose, but then you can, in the area where they choose, you can precisely measure what's going on. NOAA is using elephant seals already as their best buoys in the southern oceans to measure salinity and whatever down to a few thousand meters when they dive. And we are starting to do that with aerial samplers, birds, bats, and also terrestrial with the mammals. So it's a very exciting new way of sampling the planet, really doing in situ validation of also remote sensing models.
Okay, so what I'm gathering here, there's two kinds of measurements. One is if this sensor is capable enough, I can imagine definitely temperature, maybe wind speed direction, but just wherever the bird is, that's what these values are. And the secondary, like the salt from the seals. And the other one is where do they choose to go? That depends on the climate as well, but then you have to have a psychological model of the animal, which is a new challenge.
Exactly. But it's going sort of both ways, and that's very exciting for us because then we can predict what animals are doing, but also predict what the weather will be in certain areas. And that is then also a way to assess the long-term climate predictions. For example, El Nino conditions in the Indo-Pacific are better told by gannets, boobies that are nesting there or stopping to nest. Or we can predict the anchovy harvest in the Gulf of Mexico by the way how the diving birds, the seabirds, are bringing back their fish. But that 6 months before anybody else can predict it. So it's a very powerful tool once we start to really understand it. And that, I mean, it's the same in a guard dog or say in an avalanche dog. If you can interpret the behavior of your avalanche dog, you know where to find an animal, where to find a person under the avalanche. So it needs a little bit of biological knowledge, intuition, and linking to animals. But once you have that, it's very powerful.
Okay, no, with this family of models, I mean, there's the understanding the psychology of the animal is the hard way of doing it, but it sounds like you're also pointing to just basic correlational models. I mean, how was El Nino discovered? When you collected enough data across the world, you discovered that this patch of Pacific is 6 months earlier is correlated to rain somewhere else 6 months later. So you can say, migration patterns are affected by local weather. After a few years, you will have discovered that dependence and interpret.
Yes, but there's often a lot of uncertainty, but the animals have more certainty because they have to take a decision. Do I breed or not breed? If I breed and the conditions are bad, I die. So it's a life-death decision. And that's there's much more selection on those decisions, and animals do them very carefully, and they have evolved over eons. So I think it's a much more powerful and tested tool than any of the predictive models that we have so far.
Yeah, it makes a lot of sense. Thank you.
Yeah. So, and then obviously those sensors can be validated against real measurements like a sonic anemometer, so we can really measure the right thing, which is really important. And then you can send animals like geese all around the planet and do those measurements, or they go on their own. So you just have to know which animal goes where to know where you want to measure. But then zoonotic diseases is another one, super important. A lot of them come from animals. We have avian flu or Ebola. Let's get avian flu, a huge thing this year. These ducks, for example, they are the best samplers for that. They go also into areas like Poyang Lake in China, where these diseases are endemic because of the close connection between wildlife, livestock, and humans, and different types of livestock. We can, for example, now measure body temperature remotely of these ducks and even see a low pathogenic avian influenza. And then basically around the entire planet predict where these diseases emerge. And we can do that also now, for example, in African swine fever, a big thing in Europe, where this disease migrates with wild animals, wild boar, across the landscape. In 3 hours, we can now detect the infection of an individual. So if an individual gets African swine fever, it starts to shake its ears very differently, and we can detect it very clearly that there's a disease coming, and then the animal obviously is also dying after a while, so we see that immediately. Natural catastrophes, that's another one that I think is really important. We have systems in place since or tales, anecdotes in place since the old times in Western or Eastern history. In Japan, catfishes were known to cause earthquakes because they were always getting active before major earthquakes. There are supposedly toads that are getting active before earthquakes. So there are lots and lots of tales, but what we need to do is really measure things. We did this initially in Banda Aceh, where the big tsunami happened in 2004. Tried to get these water buffaloes and other animals that are supposedly active before something is happening. The evidence on the ground is pretty convincing. In Banda Aceh, we had complete devastation. It's a new town. People didn't really know, they were not tuned into live animals or wildlife in general, or animals in general, livestock. So there were massive fatalities. An island that is much closer to the epicenter, hypocenter of the tsunami, Simulu, which is in the southwest of Banda Aceh. There were only 7 casualties, and that is because the kids actually have to learn songs about animals. The animal in Smong, which is the big thing in the ocean that is causing the tsunami. So if the animals start to run, leave everything behind and run, and it's very powerful that only 7 people were dying on this island. Initially, we wanted to test this. We went back and studied some of the elephants that survived in Banda Aceh because they were running away. They broke their chains, and their mahouts then went with them and survived. But obviously, there's no other tsunami coming. So what we did was to go to a place that has a more sort of benign natural catastrophe, some of the volcanoes, like the one in Sicily, Mount Etna. It's not, I mean, it's known as Mother Etna because it's providing a lot of nutrients, but also sometimes a lot of destruction. So what people locally told us, we should study goats because they are tuned into their mountain and very knowledgeable about the local environment. We studied them for about 10 years now, and the last 6 major eruptions we predicted internally. We are not going outside of that prediction, unfortunately. We can't do that because that's too dangerous, but we are feeding that into or starting to feed that into the state institutions now. But there's still a lot of reluctance, understandably, because it's not wildly tested around the globe, but it starts to be looking very interesting. You have to, again, know a little bit about your animals. For example, if you have your regular nights, you always see some activity in these animal groups. So accumulating activity, but then when there's a jump in activity, you see that very clearly. It doesn't need all that much algorithms to really find that out. Then you can predict that there is a major volcanic eruption coming. This may not happen in all volcanoes around the world. This may be specific to Etna. We don't know that yet. But at least it's something that is clearly helpful in local predictions, in addition to all the other data. We tested that also with earthquakes in the Apennine area. There was earthquake series a while ago in Norcia, Fisso. This is north of Rome. You see the distribution of the earthquakes, but most of them are very small, obviously, but only some of them are really big. We studied that in farm animals, and you see here is the farm and the measurement area, measurement station. This is the distribution in 3D of all the major shocks, the hypocenters here. This is the biggest one right below the farm, the second biggest one, and so on. And they were pretty strong. Now, if you compare that, and that's really timeline comparison. So it's really almost like a stock market where you see, one stock against the other. How do they influence each other? So that's now possible because we are getting 100 Hertz data from all these animals now. And that really shows that there is predictability. We can use animals to predict what's happening there. We have this also running for a few years now. Unfortunately, there are not, or fortunately for the people, there haven't been many more earthquakes there. The last one with an amplitude of 4, we predicted about a day before, 15 hours before. So that's nice. But again, it's only a very low sample size. That's why we now would like to go to different places around the world where this is possible and see which animal can tell us what. It's not that all the animals can tell us something. This is also why for border control or for sniffing dogs, you use certain animals, and many of them are sort of sorted out. They can't do their job well enough. So this is probably the same in wild animals, but we don't know yet.
So actually, that's a good question. To what extent does species matter? Because you have these farm animals, it looked like a good selection of different species.
Yeah. We don't know yet. The best is that we found to go to the local people and say, well, what have your grandfathers used? What do you think are the best animals? Because in Sicily, I wanted to use deer and rabbits and foxes, but the herders there said, no, take our goats there. Don't take the sheep, don't take the cows there, take the goats. And then from their 200 goats, they selected the 10 most sensitive ones. Mm-hmm. So they brought them individually and said, oh, this is a good one, this is a good one, and so on. And this is how a good dog handler would do it the same way. So in wild animals, we don't know yet. There's too little information, but we think that there is a lot that we can learn in the senses, especially the algorithms, how to use the senses, the sensor fusion in the brains of animals, but also in the collective of animals, is a super powerful way of really linking information together, we think.
Makes sense.
Now, on the conservation actions, so basically our way to give back to animals is that we can use umbrella animals like these auras in Guatemala, Belize, and Mexico to protect the rainforest, and we protect them through our tags, or we use ear tags now in wild animals in Africa to learn what's happening in their environment. That can be a lion, it can be a zebra, a giraffe, whatever it is. The important part is we don't disturb the animals anymore. They are true wearables. They can have them for their lifetime. And even the large animals, as I mentioned initially, rhinos can have them all the time and tell us what's happening. We thought this would help against poaching. Well, it doesn't, because the poachers still find the animals, kill them, try to hide our tags. We find them anyways. But what the solution could be in the end is that we have other animals like this zebra. You don't even see it has a tag, but it has 2 ear tags on one in each ear that sends us a data point, maybe every 5 minutes, a GPS point, but every 20 seconds, an acceleration measurement. So really a measurement of the behavior of the animal. And we see if the animal is stressed, if it's excited, if it's quiet, if something is happening in their environment. And that can tell us whether a poacher is coming through. We already see differences between poachers and rangers dressed up as poachers, or us pretending to be a poacher. So animals see that immediately. They detect differences between tourists and hunters and so on. So very exciting. And that is something that we are currently scaling up to really do in entire landscapes. This has already worked on wild dogs in Kruger National Park. Our collaborators from Sandparks, Louis van Schalkwyk, he has done this for 2 or 3 years now with our tags, basically detecting snare risk. So these wild dogs, the most endangered mammal, large mammal in the world, or one of the most endangered ones, they had declining populations in Kruger because they were running into these snares that are set for other animals, but they hang in there and get stuck and die. Except if we know that the behavior, the movement behavior of these packs have changed, we can go there. Louis can then rescue them, and they recover. And that is really why now the population in Kruger is increasing massively compared to decreasing or dying out population even a few years ago. So very simple. Yes, you have to work your butt off to really rescue those animals in the wild, but you have the information now how to do it, and it's possible. Now, this is possible around the world. You can do this, for example, with leg bands on storks or cranes. These are black storks in the nest, so you can tag them as juveniles. They fly with these little leg bands for their entire life and send data back from anywhere on the planet. For example, this is cranes in Mongolia. These little ones that you see there, they got the tags. You see one that's sort of growing into its little trouser tag. Still looks large, but when it was about a year later or so shot in some area here where they still hunt these cranes, in that case illegally, then it reported that it was dead, and the environmental minister of the country where this happened prevented the hunting in these areas now, because they said, no, this is not good. We don't want all these animals to die. Now, this also solves domestic problems. A lot of people know that cats, pet house cats, are hunting a lot of birds. We can now have them with little tags around their neck. The tag detects in real time whether the cat is starting to hunt. So when it starts to hunt, and they behave differently when they start hunting a bird compared to a mammal, a mouse or so, then the tag is actually emitting the sound of the alarm sound of a bird, and that alerts the birds that they fly off. So the cat is basically free to roam, but alerting others that they are now sort of in bad spirits, starting to hunt, and then the birds fly away. So the cats can still have their fun, sort of trying to sneak up on birds, but birds always know beforehand because the cat is reporting on itself. Now, I think a more important aspect is that the banking system, reinsurance system has now tuned in. They understand that to have a system where in 150 years you can still pay retirement funds, you need to invest some money into nature conservation, global animal conservation. Animal conservation, because umbrella animals are the best to then sort of really guard the rest of the environment. So if they are doing fine, a manatee, a big animal, a big bird, or a big mammal, then the environment is doing okay, generally. Now, this is called the interspecies concept, where an interspecies bank holds money for a rhino or a manatee or whatever it is, a giraffe. The important part is we need daily immediate verification that the animal is okay. And that can be done by these electronic tags. I mean, as you know, they don't lie. If somebody rips them out of the ear of a rhino, you know immediately. If the rhino is sick, you know. If the rhino is healthy, is not stressed, you also know. And every night, money is paid out directly to the cell phones, the cell phones of the people around. So they have a job. They do what they love, to protect animals, because they still have them in their environment. And that is a scheme that we are now starting to test. But I think it's something that is very exciting, and it also will give not only ecosystem services, but also climate services. Animals around the planet keep 6 gigatons of CO2 from releasing it. So they sequester it, they guard it against release. That can be muskox in the Arctic or fish in the ocean, but it's a super important system to climate engineer. And if we protect animals with very little money from these banks or other funding systems, then we can actually also have a major climate effect. This is the people that are doing this in my group at the Max Planck. We have 3 of those groups at our institute. They are all really exciting young people that are wanting to change how we see the environment, how we see animals. And we think that we are now in a situation where this can be done. We can basically fly around with animals, see through their eyes, their noses, and their sensory systems, what's happening on the planet, and be able to safeguard the animals, but also change the way how we deal with that information. So that's what we think is the Internet of Animals. It's a growing field. It's a very exciting field because it's basically a new global sensing instrument that nobody expected, except the indigenous cultures always had that, but they only had it locally. Now we have it globally. And what we need is good IT. If you, for example, have people that can program things, program analyses modules, we are doing this now in a system called Move Apps. It's a Docker-based system that allows you to put together programs, R scripts, Python scripts, MATLAB, whatever it is, to analyze your data and get real-time alerts. And the better that system is, the more exciting it will be. We have that running, for example, now for vultures detecting carcasses in Africa. We have it so that the wild dogs alert us when they are being snared or when they have a high snare risk. So all of those programs are developed actually so that the people that are not out in the field, that are not rangers, but they still care about animals, they still care about the planet, that they can also contribute with their expertise. We had some programming marathon already, so some really exciting, for us at least, exciting programs were developed that alert when animals are starting to come close to a road, or when they find some specific behavior or display some specific behavior in the environment. So a very exciting way to link also the digital world and the analog world together through these programming skills that then tell us what the animals are doing in the wild. Yeah, thanks a lot. I hope you have some questions.
No, that's fantastic. Thank you very much. So actually, I guess maybe starting the hardware. Well, how much do these sensors cost? Because I'm hearing things like accelerometers. GPS is very battery intensive. So yeah, how small can you get them right now, and cost efficient, and battery life, and what do you expect to be going?
Yeah, so we are using IoT, Internet of Things technology, both on the ground and in space. You can't use the same communication protocol ground and space, because in space you have the Doppler shift, and that's very difficult for most IoT systems on the ground to deal with, or impossible. So that's why we developed the Icarus system, and now we'll have satellites doing that. The tags themselves are now becoming super cheap. We have some tags on Swifts, for example, that only cost us about $20. It's still too expensive. I mean, it's still a factor of 10 too expensive, but it's a factor of maybe 100 cheaper than what they cost on the market now, or what they did cost 5 years ago. They're also just 1 gram now. You know, we have them run on small bats now in Europe, where we have a good terrestrial IoT system. We are starting to use the narrowband IoT system for certain aspects, but we still have to do more tests, because it's unclear how far the signal can transmit on a narrowband IoT. In a Sigfox and LoRa system, or actually Sigfox is really good. We get 300 kilometers terrestrially signal transmission distance. If it's a larger tag, like the ear tag in the rhinos, 18 grams, there's a battery, circuit board, and a solar panel in a super cheap housing. I mean, the housing itself, the first prototypes cost you 100,000, but then, you know, it's only 5 cents.
Okay, so here you have solar panel on these like 20 gram or 18 gram tags.
Yes, and those ones still cost us about $100 production costs. Still way too large, but they are prototype series, so we want to get down to on the order of 30 or 40. And then for agriculture, in many of those areas, they have to be even a lot cheaper than that if you want to have them in all the cattle and those kind of things. But it's getting there. I mean, at least we have the systems. The algorithms are being used. For example, there's a tracking company, Tractive. They do pet collars, pet GPS collars, and cell phone collars. They do it on dogs and cats. They have 1.5 million of those devices out there already. So we have a collaboration with them. We put our algorithms on their units, and that means they can update them over the air. That means we have, in basically no time, we have 1.5 million sensors out there. And that concerns, for example, Istanbul. The next big earthquake is expected to be in Istanbul. Are dogs and cats telling us something? Who knows? Last big earthquake in TikTok and Instagram, everybody reported, and Twitter reported that animals were active before and told people. We don't know. There are no good data, but in the future we will have those data.
Okay, so these kinds of rollouts, yeah, and I guess I'm thinking, who will pay for these rollouts? It actually sounds like farmers may be excellent people, or
yes,
anybody for public protection. I'm thinking urban air quality things, or maybe even traffic. If you have birds that are like pigeons, I'm thinking in many cities will be rather sensitive to a lot of urban phenomena.
Yeah, I think that's exactly the most exciting part, that we don't even know what kind of questions we can ask in the future. because we don't know yet what these animals tell us. And it's almost like the internet. That's why I mentioned the Google traffic. For me, when I grew up, you always listened to the radio and the traffic information on the radio. And obviously nobody's doing that again anymore these days, because you have things like Google traffic. It's unbelievable. Nobody can imagine how the world was before. And that's how we think it will be after the Internet of Animals is installed. There are things that we can't yet even fathom that we will know in the near future.
Okay, so then assuming these are starting to roll out, one big prize is learning things about the rest of the world given these things. So we talked about weather. Probably the most challenging thing is ecosystem health. So I guess what probes do you, best case scenario, need to track how a whole ecosystem is doing? You talked about the apex animals, but the rest of it.
Well, we are actually in the process of doing that. It's called Digital for Nature. It's a concept where we want to really not even develop new sensors, but we want to bring them all together in a system that you have camera traps out there that you can leave out there, and you always know, what's on these camera traps. What are the engineering parameters? Is the battery low? Is the memory full? And all of that. But then also have that linked to audio sensors and eDNA, and have drones collect.
With eDNA?
Oh, yeah, environmental DNA. So basically, if you just sample through a river, what kind of animals have been upstream in principle. It's still a long way to go, but it's getting there. And then have individual animals in that sampling as well. The individual animals we need because we need to understand the drivers of biodiversity change. And the drivers we only get if we study individuals. We need to know where, when, and why does an animal die. So, for example, in the US and Canada, there are 3 billion songbirds missing. Huge topic. 30% of the songbirds disappeared over the last 20 years. Where are they dying? Why are they dying? Why are they not coming back? Nobody knows yet. There are lots of speculations, but the precise aspect of why an animal dies, it's detective work. This is what you have to do to really understand, where are these animals disappearing, and that's what we need to do in the future. We need to monitor who else is out there by camera traps, audio, and visual drones, but then link it to the individual animals as representatives of those animals that are either living well or dying.
So I'm thinking one mystery that's a big deal these days is disappearance of bees. And that one is unusually challenging because they're so much smaller. Is there hope of monitoring them, or maybe they're predators, or how would you?
We have tracked individual bees, even honeybees. It's totally possible. I don't know why people are not doing it more, but it's not our main focus. We don't want to do this local system, which is in bees. It's basically a local system. It's super exciting. It's totally possible, but others should do it and concentrate on the little sensors to do that. What we do know is that it's also possible on a global scale if we dedicate our effort to make a radar satellite that's good enough. We now have that's passive radar technology, but it's actually passive active. So we can have systems. Right now they are about this big still, just foils that reflect in a certain way or change the reflection in a slightly active way that you can detect all around the globe. And that is for insects, for example, for desert locusts or so. That's the way to go. So it is totally possible. It's just a question of, do we want to put billions more into things like, yet another series of massive telescopes or particle accelerators or other things, or do we first want to understand what's happening on our own planet? I think it's a question of priority. I mean, my priority is clear. I think we have invested a lot in these really exciting systems, also to explore space. But now I think it's time to explore the intelligence on our own planet, the collective intelligence, and we can learn a hell of a lot in the next decades if we put money towards it.
That's fair. Now, one, I guess, easier thing here is appeal to cross commercialism, ecosystem services. So if you can start quantifying, like that's why I actually went to honeybees. They make money, so somebody would be theoretically willing to just directly pay for that service. So it's rather difficult to quantify ecosystem services provided by animals or sensed by animals. I'm now thinking the service of planting trees upwind in a deserty area so that the sand does not shower on somebody else. It's a very different service. So how much you measure such ecosystem services?
Well, I think that's possible now, and it's part of this interspecies money. So we have the first system is going to go up in Rwanda on straw-colored fruit beds. These beds are actually the most numerous mammal species of Africa. There are probably 100 million or so of them around. They plant on the order of 1 billion trees every night in areas where no other animal goes, because they fly over 100 kilometers over desert or deserted landscape and spit out the seeds or shit them out. And they start planting trees and in savannas, regrowing them, re-greening them. And those ecosystem services can easily be quantified in terms of funding and in terms of the money that is needed to keep them alive. It's not a lot. I mean, you only need to protect them locally, and then they're doing totally fine. But you can do that in many different ways, and you can also do that for, say, the muskox climate service. That's quantifiable, and I think that's very exciting. You can have biodiversity credits as you have carbon credits, but the nice thing about the biodiversity credits is that they do both. They keep biodiversity happy or increase it, and they keep the climate in check. And I think both is urgently needed.
So a muskox climate service, that's a measurement of climate, or is it like...
Well, you can have muskox in the Arctic, and they graze the bushes, because in the high Arctic it's getting warmer. Bushes grow, and if the muskox are there, then they feed on the bushes, they graze them down, which means that the albedo at night is there's more reflection, so it's staying colder at night. So the heat is, or the heat during the day is being reflected, staying colder, and the permafrost is staying longer, and that means that no methane or other gases are released. And if you line this all up, if you sum it up, then you have a massive climate effect, preserving all over the planet, with all animals, roughly 6 gigatons of CO2. And that's why, doing this in other ways is almost impossible. It's dangerous if you want to, for example, do sulfur delivery in the higher atmosphere to simulate a volcanic eruption. It's pretty damn dangerous. I wouldn't like to be on the receiving end of that. But if you do it by animals, just prevent the CO2 release or sequester CO2 and other gases from the atmosphere. It's totally possible. It's cheap, and it's also helping biodiversity. So I think that's the way to go. It's a super rapid, immediate way how to do this.
No, that makes sense. Now, if it's carbon offsets, it's one of the less nasty problems, because you can quantify how much was emitted, how much was sequestered. Yeah. That's regular hard. The dollar value of an ecosystem staying healthy is much harder. And that's, I mean, now you're starting to measure this stuff. So this is kind of where I'm really leading with these questions is best case scenario. I have a simulation of an ecosystem and saying you did bad, ecosystem changes like this, its dollar value is lower. You did good, you fixed it. And it's always non-linear. It takes usually much more time or money to fix it than to damage it. But that we do not even have that understanding.
Oh, I see.
But some of these sensors are getting us there.
Yes. So now I see your point. I think that's a really important point, and I think that's what the banking system, the interspecies money for animals, is doing. Because what we need is so in a way the ecosystems are a black box. We can't measure everything, but we have our indicators. And the indicators are almost like our guard dogs. They tell us what's happening, and that can be a rhino, it can be a giraffe, it can be a zebra, whatever animal is the right one for that environment, or it can be a bear or a wolf, or it can be a caribou. So if we make sure that those animals are safe and healthy, then we know the rest is safe and healthy, even though we don't yet understand all the connections, all the details of this ecosystem. So I think it's really good. It's almost like in your car you have a temperature meter for or nowadays a battery meter for the state of the engine, and you don't know exactly where it's connected, where your battery is, where the current comes from, but if the level is going down, not good. If it's going up, better. And that's what the rhino or the zebra can tell us. If they are doing fine, ecosystem is okay, and we give the payout. And if they are telling us that they're either leaving the area or they're getting sick, they're dying, then bad choice.
Okay, so it sounds like what you're kind of focusing on is this is the indicator. And
Yes.
if you have additional information about what is being done to the ecosystem, in what way it's being protected or damaged, you can start developing the mechanistic model of how the ecosystem is operating.
Yes. Except I would find it dangerous to think we need to first understand the entire ecosystem to act.
Yeah.
So I think, this is like, if I'm going skiing in the winter and an avalanche comes and I'm below the avalanche, and if I hear a motorized vehicle, I think, oh shit. If I hear a dog barking, I think, oh great, now they found me. So I don't know how the dog found me. I don't care, not the least. It will remain a black box for me for a long time, until I really understand how a dog perceives the sensory information, processes it in the brain. It's going to take decades. But meanwhile, I'm happy the dog was there to bark.
No, that's absolutely true. The challenge is, and I'm looking for, making the full story. People lie like crazy. And carbon offsets, the recent disasters of them, are people lie innocently. Where they mean to do something good, but they make an honest mistake, or just like edge past the danger zone, just innocently, but self-interestedly. As a result, there's a lot of well-deserved skepticism about, are you really doing something, or would the good thing have happened anyhow? Which is why it's hard to get money other than nonprofit money, which is not nearly enough. But real money comes from people who distrust, expect to be lied to. So this is what I'm trying to figure out, to what extent we can make reliable models or forecasting-based models that can have some validation to make people comfortable, in dumping money.
Yeah. Well, I think, again, it's the immediate verification of the ecosystem processes that you get from indicator animals.
Yeah.
And we're actually doing that in rivers, for example. If people drink river water or lake water, whatever, you often have fish or little small limbic organisms that you monitor. So you have a tank and it's full of water flea. And if a specific type of water flea is doing poorly, then drinking water is not so good anymore. Or if certain sensitive fish are dying, you say, oh, no, stop drinking that water. And that's the same thing we can do in any kind of environment. And then if we treat parts of the environment differently, and animals choose the part that is being treated or being remedied, then we have instant gratification, instant validation that what we did is good or what we did is not good. And I think that's what we need. Without a complete functional and causal knowledge of how everything is connected, well, it's going to take a long time to understand that. But the animals have done this for millions of years, and they tell us immediately.
Okay. So what I'm hearing here is, the foundational role that measurement plays, so that, let's say if you have 10 projects and some of them are working, some of them are not working, in 10 years you will know, or 20 years you will know, even if you didn't know ahead of time which of these interventions were going to be successful. And the other thing you would need is a good set of controls for these projects. Even if you don't know why, you do have a forest that was not protected, so you can at least compare the treated to the untreated. As long as you have measurement and a control, the mechanistic understanding becomes a lot less important.
Yes. And for example, in corridors for animals, wildlife corridors, we did that for fisher, these huge weasel kind of things in even bigger, that roam, for example, in Albany, New York or so. People were trying to build from a human point of view. They were trying to build overpasses or underpasses or whatever to sort of protect them from being run over by cars. What we did was ask the animals, give them a cell phone, basically, and let them communicate what they see and what they do. And that's very different. They used very different areas to cross roads and areas where they wanted to hang out. And in many cases, it was much cheaper to solve the animal problem, the problem of the animal, or for the animal, than to build a huge overpass. So it's saving money, and it's making the life better for animals if we ask them directly.
Oh, that's actually, now you're talking about mechanistic understanding of animal motion, because you watch them go, and you can actually design intervention based on that mechanistic understanding. It's incomplete, but you have a very detailed view.
Yeah.
All right. So one thing in the few minutes we have left is I've asked you about sensors, and you were pointing to some of the IoT infra required to actually track them, but we've been talking about some pretty remote places. So where is tracking available? Where is it challenging to provide it? Because I'm also noticing things like high altitude locations would be fantastic for measuring the atmosphere, but presumably difficult to track, or oceans.
Yes. So, oceans is a difficult one. Oceans, you can't get signal out of the ocean. The water-air boundary is a really bad one. But there are really good groups in California doing that in the oceans or in the East Coast. So I think it's doable. It's a different wavelength that you need in most cases. But the rest of the planet, it's pretty straightforward. It's almost like 20 years ago when you had your cell phone and you go from the US to Europe and it doesn't work anymore because, it doesn't know which frequency to switch to. This is now changing. So we're actually actively providing systems that can search for the right kind of IoT in wherever they are. So if you are in a city, our tag uses narrowband IoT. If you're out in the countryside, you need 200 kilometers range, but you are in Europe, you use Sigfox. Easy. If you are going over the Mediterranean into the Sahara, you use the Icarus system. There are different technologies that you need to then link to. But in principle, this is all now doable on the same chip. It's similar frequencies, 400 to 900 megahertz. So it's all completely doable, that seamlessly the tag on the animal can choose its own communication channel, and the AI on the chip will decide what to communicate. So we already have some good models, like in the pet cat, where the tag decides how to alert the rest of the environment or what kind of signal to send. And that's an intelligent sampling on the tag, makes it so much more efficient, and then also knows how to communicate. And that's, I think, the future.
Okay. And for batteries, because the other one for communication can drain it pretty badly. So, I mean, for the heavier things, solar seems to be effective at a cost. And to what extent can you have like ambient power generation? Things so
Yes. So we have, I mean, on the one hand, we are now using capacitors instead of batteries, which is much better because they live basically forever. And we have also used energy harvesting. They're still too big. I mean, we use the ones from the watches, sort of remodeled in certain ways. I mean, these wristwatches that you twist and shake, they're doing okay. They're not perfect. They don't produce as much energy as a solar, but they can run forever in principle. So that is coming. But there's another point, and that is obviously we want these things to be wearables. So animals shouldn't even recognize that they are being tagged, or they shouldn't have the stress of capture. We always use a stress. So now we are already developing systems, for example, for deer, that they are automatically tagged. They go through a little hole, little box. There's a salt stone where they lick, and while going in there, they get some tag on the ear or around the neck. Or there's a nettle gun that we, a little bow and arrow principle, that you have a nettle shooting to, say, the huge beard of an orang. So it hangs in there as they have regularly. I mean, they have twigs and they have nettles in there, and there's just an electronic nettle. And that gives you a really good information for a certain amount of time, and then they get the next one. So that there are many different ways of optimizing that once you have the right kind of mindset. And I think that's then super exciting, because you can ask all kind of animals around the world how they see their life around them.
Okay, that's fantastic. Well, yeah, thank you very much. This is fascinating and really valuable, and hopefully, like in the audience, we'll have some takers to actually like help you out, and maybe ways of channeling funding.
Yeah, it would be great. I think it's up and coming. This is, once people have that information, they never want to give it up anymore. Like the weather forecast, you want to have that every day. In the future, the life forecast, you want to have it every day. You want to understand what life is doing on the planet, and this is the future.
These are unusually smart and valuable sensors that happen to be animals and happen to also view ecosystems, which we have practically no insight into.
Exactly. Yeah.
Fantastic. Well, thank you very much. Have a great rest of your day, evening.
Thank you. Yeah. Bye.